Project management is a key aspect of the job description of every security auditor, and that's what we're going to look at here in Part 1 of Systems and Infrastructure Lifecycle Management. As a project management professional, you would learn the same type of techniques that were used to rebuild the Pentagon after 9/11, to transform IBM from a successful IT hardware company to an IT software leader, as well as organize and manage the Olympic Games. As a matter of fact, CBT Nuggets offers an entire project management professional video series of 30 videos towards the PMP. However, in the CISA, we need only to look at a small segment of project management. That's what we're going to do in this first of a three-part series on systems and infrastructure lifecycle management, starting here with project management structure. There are a bunch of different approaches to performing project management. Some of these look at a systematic view, others on a holistic view, others focus on software development, security policy development, others have detailed workflows for creating documents. The good news is there are some prominent de facto standards, and one of those is the PMI, the Project Management Institute, with its Project Management Body of Knowledge, or PMBOK. If you go to pmi.org, you can find information about this body of knowledge and some of the newer standards and documentation up there. For example, in the bookstore, you can get the government extension to the PMBOK guide. The Project in a Controlled Environment, or PRINCE2, is also a de facto standard. You can learn more about this project management standard from ogc.gov.uk. PRINCE2 is a recognized world-class international product and a standard method for project management. Or finally, there's the IPMAHR, the International Public Management Association for Human Resources. Now, whether you use PMBOK from the PMI or PRINCE2 or IPMA, the bottom line is each one of these methods, organizations, and systems have their own pros and cons. But there are several things that are common across all the different project management methodologies. And I want to focus specifically on those as it relates to the CISA. A project is defined as a time-sensitive effort or an assignment of tasks with a specific goal that is deliverable within a certain time frame. A directive that can be accomplished in measurable terms. Projects, by definition, have a start date in time and a stop date in time, and are divisible or broken up into multiple segments. These segments are also referred to as phases. A project can be a simple set of tasks, or it can be a complex effort that has elements of risk involved, in the sense that if the project isn't completed within time frames and budget, it can have a detrimental impact on the organization. Typically, a project begins with a charter statement, or a mission statement, and it ends upon the completion of the task. Projects can often contain sub-processes or sub-projects that fall into these categories: the project initiation, project planning, project coordination, project execution, project management, this is misspelled, sorry about that, discontinuance of the project, and project closing. It's vital that the project manager look at the project in terms of its importance to the organization, the overall business goals, its connection with the organization's strategy, the relationship between this single project and other projects, and the connection or linkage of this project to underlying business goals. Typically, several projects are running simultaneously, so the relationships between those projects is really important. You also need to know that there's three major forms of organizational project: influence, pure form, and matrix. The influence project organization form is where the project manager only has the staff function. There's no formal authority by the company or the organization. In the influence form, the project manager is only allowed to make advisement to peers or suggestions to team members as to what activities should be completed. In other words, they only have an influential or advisory role. In a pure organizational form, the project manager has formal authority over all those individuals taking part in the project. And with the matrix project organization, management authority is shared between the project manager and various department heads. If you're an auditor, you need to understand which one of these organizational project forms is being used. Let's look at an example here of a sample organizational chart used with project management. And let's say as an auditor, you're not actually performing an audit per se, but you're functioning on the product as an advisor or in an advisory role. As mentioned before, here at the top, we've got the steering committee or the steering group, which will include the project sponsor or sponsors, someone from senior management, possibly the CIO, user managers, departmental managers, and of course project managers. You may also have in this matrices here, an analysis standpoint, a quality assurance individual. And then of course underneath the steering committee, you've got the various teams or committees that are going to actually undertake specific parts of the project. System development projects team, the user projects committee, the system development or the technical infrastructure, and then finally possibly a security officer. Underneath system development management, you might have software support, hardware support, and network support. Underneath the user projects team, you'll have power users. Under the system development projects committee, you'll have systems or application analysis and or programmers. All of these players together make up a project management independent social system. From a practical standpoint, project management is really applying a wide variety of components, tools, hardware and software, techniques, skills, acquired knowledge, all of these things to a broad range of tasks to achieve the stated objective. There are three elements or aspects of a project that should always be taken into consideration. And these three elements are time, cost, and deliverables. This is often shown in a triangle kind of diagram where you have cost and resources up here at the top, time or duration at this corner, and deliverables, the end result, down here. All of these together equal your project. The 5 steps of practical project management can be broken down into initiation, planning, managing, controlling, and closing the project. The project will be initiated by a project manager or a management sponsor, putting together all the data needed to get approval for the project from management. This will generally be in the project charter, which is a written document that gives the objectives of the project, the stakeholders in the system to be produced, and the project manager or managers and the sponsor. Once the project initiation document or PID is approved, you've now got authority to begin the project. That's when the planning stage occurs. In the planning stage, the project manager should figure out the various tasks that must be performed to get the expected results, the sequence or the order of these tasks, the duration or the time window for each task, task priority, the IT resources that are available and necessary to perform the tasks, the budget, and a source and means of funding this project. A common methodology for estimating complexity when developing a large business application is FPA, or Function Point Analysis. FPA is an ISO-recognized method for measuring the functional size of an information system. This reflects the amount of functionality that's relevant and recognized by the user in the business. It's independent of the technology used to implement the system. FPA uses what's called function points. For example, the size of the system in the project may be 312 FPs. For example, here's the International Function Point Users Group, which is a nonprofit website dedicated to individuals using function point analysis. You might want to add this to your knowledge base to find out more information about FPA. Another part of planning is determining the amount of effort, and as far as money goes, that will be necessary to carry out each task. You should estimate each task based on personnel hours, machine hours, and other external costs like third-party software, licensing, fees for consultants or contractors, training, and certification if necessary. Also part of this is estimating the cost of software for the project. These costs can include cost of the source code language, main storage constraints, data storage, access to computing systems, security, staff training, those types of drivers. Also part of planning is scheduling and establishing the time frame for your organizational project. You can use various techniques like Gantt charts or PERT diagrams. And all project planning takes into consideration what's called critical path methodology. CPM, or critical path analysis, is a mathematical algorithm for scheduling a set of project activities. It's a very valuable tool for effective project management, and it's used in a wide variety of different projects like software development, research, product development, engineering, even construction. Any project that has interdependent activities can apply the critical path method. The essentials of CPM are: 1. Have a list of activities necessary to complete a project. This is a work breakdown structure. And then 2. Have the time or duration that each activity takes to complete. And then thirdly, the dependencies between the activities. With these values, CPM calculates the starting and ending times for each activity and then figures out which activities are critical to the completion of the project. That's what's called the critical path. As far as project management is concerned, a critical path is a sequence of project network activities that have the longest overall duration, which helps us determine the shortest time possible that we can complete a project. There's a bunch of software solutions out there that use the CPM method, even though you can still use CPM with just a simple pen and paper. Let's take a look at the list. Here's 4 different categories of project management software: open source applications, free web-based applications, commercial desktop applications, and commercial web-based applications. Another common time management technique used in the planning phase for software development is time boxing. Time boxing splits up the project into a number of separate time periods, typically 2 weeks to 6 weeks long. Each time box has its own deadline and its own budget, and then by finishing one part at a time incrementally, you can deliver the project successfully. With time boxing, the dates aren't flexible, but the deliverables are. The deadline is fixed, but you can adjust the deliverables based on agreements with customers or users. Individuals often use time boxing for personal tasks as well as project management. Talk about managing your project. It really comes down to automation these days. Everything's automated with software. Automated proposals, doing cost estimates, budgets, automated monitoring of the project, making predictions, and then generating reports and summaries. This includes what's called DSS, Decision Support Systems. These are automated tools for planning and controlling project resources. Also, during the management process, we're going to use PERT and CPM techniques. And of course, all on the way in this process, we want to do full documentation. Again, that can also be automated with reports generated from the software. Now, the 4th step here is controlling the project. And this is really managing the scope of the project, the usage of the resources, and managing the risks involved in the project. Needs that pop up should be well documented and approved. And then, of course, you need to apply or allocate the right resources to the new task or the new requirement. And control deals with completing the project within the stakeholders' time expectations, using the funds and resources properly, and meeting quality concerns, quality objectives. And then finally, the 5th step of the practical project management is closing the project. It should have a finite finish line. At some point, you're going to close down the project and then possibly create a new project or a modified system project, which will be undertaken or handed off to other users and support staff. Whoever the management person is who's sponsoring the project must be completely satisfied that the end result was produced, acceptable, and ready for delivery. This may also include contracts, for example, and other types of documentation. In the closing process, you may have a formal post-project review where you kind of look at the lessons that you learned, you assess the project management processes, and you document and you reference for the future information that other project managers and users can use when they undertake new projects. Most companies are going to designate a large number of IT resources like personnel, time, and money, applications, facilities, and technology to the process of developing, acquiring, and maintaining business application systems that are key to the effective functionality of key business processes and business units. These systems will also often control critical information assets and data that should be considered to be effectively managed and controlled. The managing and controlling of these resources is part of the life cycle process of project management and business application development. The implementation process for business applications is commonly referred to as SDLC. SDLC stands for Systems Development Life Cycle. It's also referred to as just SLC. It's defined by the U.S. Department of Justice, and it's a software or application development process. And it's known for being independent of the underlying software or IT considerations. It's often used by system analysts to develop an information system, looking at requirements, validation, training, and user ownership through a wide variety of processes. SDLC is also known as Information Systems Development or Application Development. Another alternative model is the Verification and Validation model, also known as the V model. This is going to emphasize the relationship between the different phases of development and different testing levels. For example, the most granular test you would do is called the unit test. And under this model, a unit test is going to occur right after the program has been written. For example, testing will also occur to validate your detailed design. System testing is going to relate to the architectural specs of the overall system, while the final user acceptance testing process is going to reference the requirements of the application from the end user standpoint. Now, regardless of what kind of model you use, SDLC, which is known as the waterfall technique, or V model, the system is going to be either organizational centric or end user centric. The purpose of an end user centric model is to give different views of the data or the application depending upon their performance optimization from an end user standpoint. Most end user centric models are alternative approaches. The most standard, the oldest, most widely used approach is the waterfall technique, SDLC, which is an organizational-centric model. Even though there's several variations on the theme, let's look at a traditional systems development lifecycle approach. The feasibility phase is where you actually sit down and figure out any strategic benefits of implementing the application, either from productivity gains, maybe avoiding extra costs in the future, looking at the cost savings of the new application, as well as other intangible factors. What you do in the feasibility phase is going to provide the justification or the reasoning for moving on to the next phase, which is the requirements phase. In the requirements phase, you're going to determine the problem or the need that requires a resolution, the challenge that the application is going to address. It's going to define the functional requirements and the quality requirements of the application solution. Now, this approach could either be customized or it could be a vendor-supplied application. Regardless, the user has to be closely involved in this process. In other words, the person who's going to be using the actual application on the end user side. Whether it be a host-based security suite that you're developing, maybe a front-end customer service application, maybe it's a leads management software for your sales force, perhaps it's a travel and scheduling application for mobile teleworkers, or perhaps a just-in-time inventory tracking system. Regardless, you have to look at the requirements. Now that leads to the next phase, which is really a two-part phase, design and selection. Based on your requirements, you're going to establish a baseline of system, program, and subsystem specs that are going to describe the parts of the application. How they're going to be interfaced. Are they web-based? Are they proprietary? How are you going to roll out based on your chosen hardware, platform, software, and network infrastructure? This design phase may also include application specs, database specifications, security as well. You also want to put into this process a formal modification control process to make changes all through the development process. And then 3B here is selection. You're going to put together a request for a proposal from suppliers or vendors of pre-packaged systems, or you're going to look to your development staff to program or manufacture a custom solution. Once that decision is made, it leads to the development phase, whether it's done in-house or by a chosen vendor. Of course, the development phase depends upon whether you insourced or outsourced or just developed a prototype for a vendor. Regardless, you're going to use the design specifications to start programming and formalizing the operational processes of the application. This is going to include many levels of testing all along the way to verify and validate what you've developed. This is going to include all the unit testing, all the system testing, as well as getting user acceptance testing and user acceptance feedback. Next is the configuration phase, where you're going to actually configure the pre-packaged system to modify it to your organizational requirements, or using the flexibility of custom solutions to suit your organization by just modifying and adding certain functionalities, setting different parameters, and so forth. Then comes implementation, where you actually establish the actual formal operation of the new information system or application. This is where the final stage of user acceptance testing is going to happen, and sign-off from the management. Your application may also go through a certification and accreditation process during the implementation phase. And then finally, you should have a post-implementation phase. After you successfully implemented your new solution, you want to have a formal documented process that assesses how adequate the solution was. Did it meet all your goals? Where did it fall short? Maybe doing a projected cost-benefit analysis or a return on investment analysis. Getting additional feedback from the end users and the IS project managers to help you when you develop your next project, your next application, or to help you when you go back to the drawing board on this application. Now, this is a traditional SDLC approach. There are other modifications. For example, there's an SLC, Systems Lifecycle UK version, that's slightly modified. All of the steps are really in there. It just has 7 different labels. Let's take a look at those. You know, it may be that the British are just more careful and deliberate than the United States. Over here in America, we kind of have that cowboy maverick mentality. We tend to jump in a little bit quicker. As you can see from this SLC, it isn't until the 7th phase where you actually implement the application. In other words, you've got, first of all, a terms of reference phase where management decides what their objectives are for the new application. Then they do a feasibility study to find out if management's concept is even achievable. Is it realistic in terms of money, time, personnel? At this point, you may simply just decide to do upgrades to the existing application rather than create a new application. Then, of course, the UK model is going to do some fact-finding and recording and some further analysis. Finally, in step 5, we get to the design. In the design phase, the designers are going to produce 1 or more models or prototypes of what they actually see the system looking like. So they're going to have ideas from the analysis phase, and they'll pick and choose the best ideas. You'll have a document produced in the design phase that will describe the application and the system, but it's not going to be overly specific. That part comes in the next phase, system specification, where you decide upon a generic vendor solution or a custom solution. Now's when you have very specific, exacting models, brands, and suppliers for each application and or hardware. Finally, in step 7, we have implementation and review. This is combined into one phase, into one step, where you set up and install the new program and application suite, review the results, and discard the old system once the new application has been proven reliable and stable. As would be expected, it's important to realize that there are some risks to business application development. For example, if any way along the process you determine that the system or application is not going to meet the user's needs or the user's expectations, that's a risk. Finding out as early as possible in the process is going to be helpful. Also, there's risk from the application project exceeding the budgets for time, for money, or personnel resources. There also may be a lack of discipline or lack of support from other departments, other units of the business in supporting the infrastructure of the application. That's always a risk and a real-world possibility. And then, of course, risks are going to come when you fail to review and document every step of the process. In this CISA nugget on Systems and Infrastructure Lifecycle Management Part 1, we looked at 4 key subjects. First of all, project management structure, then project management from a practical standpoint, business application development, and software development risks. I hope this nugget's been informative for you. I want to thank you for viewing. We'll see you in Part 2.